Hi, Molly.
Hi, Emmet.
So you recently wrote a very interesting, maybe even provocative blog post where you laid out the possibility that we're entering a new age of UX. And you wrote a bunch of interesting things about how designers working with AI products need to evolve their entire design approach. And I thought it would be something that our listeners might get a kick out of diving deeper into and so on. Maybe to kick us off, you can kind of outline the high level thesis of your blog post.
I mean, originally this was meant to kind of help some of our designers internally and product managers to learn what they might need to consider as they start working with AI. We see so many new products out in the space using LLMs, and it really, it democratizes AI for like a new generation of designers. I think there's still a lot to learn about the systems, even though they're simpler to use, but like how users react to these systems can impact a lot of the design process that designers need to do.
And a lot of designers are perhaps being put in a position where they're either curious and they want to learn how to design with these tools or for these types of AI systems, or they're being asked to for work and they're like, right, well, how do I tend to approach this? And I think one of the most interesting high level point was like, in a very different way, right, is the answer. A lot of the traditional design processes that we might have used for older systems don't necessarily apply when you're designing for AI systems.
I'm kind of thinking of it as like design and like when you're doing improv, right? Like you still need all the design stuff and process and knowledge and skill that you're used to having, but you have to add a bunch of things in that. So I have kind of a diagram in there about layers I think you need to add to like the typical Jesse James Garrett 5-layer like interaction model. And so I think a lot of that is around system design and data, and thinking a little bit differently about how users might react to the fact that like the system is now kind of taking control of things at various parts of the user journey, and what that means, how they react to it, and what implications that might have.
Yeah, before we go, and you outline like 5 kind of things for designers to keep in mind, and maybe we can go through them. Before we do that, I wonder if you could just to help people understand what we're talking about. One of you tended to almost map out like an old way versus a new way of approaching design, and the new way as these additional requirements that you're talking about. In the post, I think you talk about the old way being more deterministic and the new way being probabilistic. Maybe you can like explain what those two terms actually mean in practice, and what the main differences between this old way of designing for a system and a new way is. So what do you mean by deterministic versus probabilistic systems?
Yeah, deterministic is kind of you set guidelines and then the system follows those guidelines like pretty consistently and strongly, right? So if you're doing, if you have a calculator and you're putting in a math problem, you put in the same input every time, you get the same output every time. It's determined, it's kind of predetermined in that sense. Probabilistic, designing for a probabilistic system, there's a bit of chaos that gets thrown in there. And so you don't always know, there's maybe a range of similar outputs you might have for like the same inputs, but it's not guaranteed. So there's always some surprises in there. And so part of the process of designing for AI systems now is learning how to deal with those surprises and design with them and design around them.
So for these older deterministic systems, when you're designing them, you kind of know exactly what you're going to get out of the system if you query like a piece of data or something like that. It's very mathematical, very predictable, very bounded. And with the more probabilistic systems, you're getting a response from an LLM, and it could be slightly different every time. It could be totally not what you expected. And part of the challenge of designing for these AI systems is you got to wrangle that into submission, and you got to figure out how to make it. And so maybe in the past, we relied on this very like easy to anticipate double diamond process, right? Where we do like some divergent exploration and then converge on a direction, then diverge again on the solution, and then finally converge. It's not quite that way with these AI systems because it can surprise you. It cannot give you the results you expect and so on. So Molly, you have very helpfully provided us with these five rules of thumb or so on, you might say, and maybe we could talk through those. So the first one that you talked about is it kind of all starts with data and the quality of the data. Maybe not something that designers, again, typically think about from the start. So maybe talk about that.
Yeah, data makes ML systems and probabilistic systems, right? They're trained on it. It's also inputs as you are using the system. And I think, in typical design for deterministic systems, you can very quickly get a sense of, oh, okay, this field, this attribute like contains this type of thing. The probabilistic system, if you don't have a really good sense of what's going into it, you can't necessarily get a great sense of what's going out of it. So I quote in there the like data scientist's favorite saying, like garbage in, garbage out. And for the uninitiated, like a lot of the work of a data scientist is like data cleaning and transformation and making sure that like you know what's in there and that you have the right data there. And so as we translate that to like I'm a designer now working on an LLM system, the data input's a little bit different because a lot like most of that has actually just been kind of internalized into the LLM. But kind of how I would define that now for a designer working in it is like to really understand the range of potential inputs and how those translate to a range of potential outputs. So you really understand the shape of the data that might be going in and like how that might shift the output of the LLM.
Do you think designers need to get more technical? Like I'm not necessarily into coding, but you do need a high degree of understanding of how the system is going to work on a technical level in order to design for it. Is that fair to say?
You do, but I feel like it's a little bit different. Maybe it's not like you need to suddenly learn a bunch of engineering, but I think of it as like system design, systems thinking is really helpful here to understand how if you have like multi-step processes that involve AI at different pieces, how things can shift as you go through that process, and understanding how choices you make on this part of the system or with this data input actually have like downstream effects with other parts of the system that are now ingesting like outputs from here and how it relates together.
Just to make this one a bit more tangible, what's an example of like problems of dealing with data, either data in or data out, that where this actually becomes relevant to a designer's or a design process?
Yeah, so an example for us is like our Fin AI chatbot, and this is based on a like what is called RAG model, retrieval augmented generation, where you're retrieving a set of data of information and then using that to generate an answer. And so, for this, the chatbot is really only as good as the knowledge and the data that it has, and so that means what is in your help center? What is the quality of that knowledge and information? We can only kind of work with what we have there because we've put in a lot of controls to make sure that Fin doesn't like make things up out of thin air. And so Fin only really knows like what information you have available.
It's a good example of a lot of the complexity going under the covers, so to speak, with these new things. I know a lot of people maybe talk maybe superficially about, oh, the UI can go away if you can type a command into a box somewhere. But a lot of the product complexity is being squirreled away behind this simple chat interface. In the example you just gave there, the RAG example, the designer does need to know, oh, I know it looks like you asked a question and you get an answer back. But what's actually going on is we're old school searching our database for related articles, pulling the content from them, sending those over to the LLM. So all of understanding what's going on under the hood there is necessary because it affects things like latency. And so you need to design around all of that as well. Yeah. Okay. So data, understanding data, connecting with it and what's possible and the quality of it is the first thing. Then you went on to talk about the design process and how, typically people might start with a low fidelity in the traditional design process and then work up to higher fidelity. But an approach like that, that's kind of somewhat linear, doesn't tend to work here.
I think it's still, I think it's actually even more important to start with really low visual fidelity. But the difference, I think, is I often see designers who have low content fidelity in their low fidelity prototypes. And so they might have lorem ipsum, or they have like squiggles, or they just have like fake text. And in this case, I think it's quite important to have like a real output, real potential outputs, like a range of potential outputs where the content that you're actually putting into your designs is full fidelity, essentially, is full fidelity. And then it allows you to show, to do user testing or something with a low visual fidelity prototype. So folks like don't expect this to be finished necessarily, right? You don't overset their expectations, but where they can actually see, is there value in this output, like in the AI output that I'm seeing? And so they can actually judge it. Whereas if you show something like really beautiful with like totally fake text that you just like imagined, that's not real, it's of course easy for somebody to say like, oh yeah, that's wonderful, I love it. But like, you still don't know if you can actually do it.
What if this imaginary text was relevant to you? Would this be a good product? People are, I guess it would if it was, but it matters, right?
Right. Right.
So how do you test those things then? You're getting into prototyping earlier and getting that like real data for real customers in front of them and like effectively building these systems sooner, or how does it work? How do you approach prototyping then?
Often, I think it also involves like more of a more iterative relationship, like with your engineers or your machine learning or data scientists, to look like get in there early on as they're starting to build something, give insight around the design that allows you to like cut a bunch of steps out later, right? If you have user insight that's like, oh, we need this to be like 3 things instead of 1 thing, that's important information for the system and the engineers. And it becomes like much harder to change that the further along you go. And so we work together like quite early on something where, we might be in like a spreadsheet or just in code in like a Jupyter notebook or something, looking at outputs, doing what we call back testing, where we're looking at real data in the past where we know like what the outcome was. And now we're comparing that to like what the new outcome might be with, these new changes or this new design. Often that might be qualitative to start, and then something that we might launch as like an A/B test to customers, or just show them in like research sessions to get qualitative feedback. It kind of depends on the feature and like the interaction and like what kind of volume we might have available to get data from, basically.
Well, one of the things I've noticed as we at Intercom have been working on these features is like just how qualitative the assessment of the performance is, and how you end up trusting the engineers and designers that have spent the most time actually just hammering repeatedly on the thing. And I think more than the deterministic systems, you need to spend a lot more time just kicking the tires on the thing and trying to break it and get a feel for it yourself. And eventually you build up a strong intuition. And I've seen it happen even internally, this kind of tipping point where the intuition goes from, we're not yet sure it's going to work. It's a great idea. And if the technology allows it to work, to like very suddenly almost like, oh, we've now passed the confidence threshold. Let's make it live. But there's almost a build up of uncertainty until you cross that threshold. Is that how it works? I'm giving my outside view looking at some of these projects. What's it like from the inside? And my real question is, how do you get to that confidence point where you're like, oh, I've seen enough anecdotal evidence that convinces me that this is good, useful, doesn't go off the tracks very often, etc.
I think part of that is having a strong shared sense of like what I'd call like design principles for what we think the quality or the output bar of this is. I think your take there is pretty accurate, where it's like there's a period where we're like not sure if this is going to work at all, even if we're watching test results or if we're doing it qualitatively. And then at some point you learn something where you like learn something new about how to like change your prompt up, you like add some new piece to the system, and suddenly that change now feels like it's opened a door, right? I do think that has happened. I do remember that journey on Finn, where we started out being like, this is like not going to be possible at all. And then had a moment where I was like, to the engineer, I was like, this is actually pretty good now. Like, we should show it to the rest of the team. And then still a long period before we felt like it was launchable to customers. But it can be kind of steps sometimes, right? It's not like a smooth process, but you like step up and get closer to where you want to go. And sometimes that feels sudden and surprising.
It's certainly, I mean, the nearest thing I can equate it to from the way we used to design, or if you were designing again for a purely deterministic system, is like things like form validation, or, oh, someone trying to do single sign on and it doesn't work, or something like that. Lots of these failure states, but none of them are like critical to the success of as in, none of them are determining whether or not the the product should go ahead or not, or is viable. And yet we actually have that sense of like that interplay between the designer and the engineer having to figure out those failure states, those, all the different problem situations, and you list them in your blog post, right? The cold start problem, the empty text box, and the what do I type into, the discoverability, false positives and negatives, and so on. So it is like that validation problem on hard mode, I think. Yeah.
Well, and with deterministic systems, like with form field validation, like, you can solve it. It's just how do you want to do it, right? Like, there's a solution. With new AI stuff, there might not be, like,
it might be
or
your
rather, like,
showstopper. Yeah.
there might not be yet, and maybe that's different next week.
Let's move on. So the third thing you talked about, kind of related, or maybe we're segueing into it naturally, is around failure. And I thought your statement here was funny. It's like, plan for when, not if your system is going to fail. So that almost seems like a foundational, like, new place to start, right? About deterministic systems. They're always going to fail. Is that what we need to expect?
Yes.
Well, not always going to fail, but they are definitely sometimes going to fail, more accurately, is what I mean.
They're definitely sometimes going to fail. They'll fail sometimes in ways that surprise you. And so do your best to be surprised the fewest times possible,
Yeah.
I guess is the goal there. And that's really going back to like testing and understanding the data and understanding like potential outputs, just so that you have a chance to design for those.
I liked your rule of thumb here a lot, which is, if you are surprised by how the like live production version of the product is working or is performing, then you didn't test enough. But again, it speaks to probably, there's a whole other, by the way, parallel podcast episode that we could put on, which is like how to research and validate these systems as well, not just to design it. So that's super interesting. Okay, so then the next part of the system, we're finally getting to where we often start in again, more traditional types of design, which is the user, the human. And here, I think the most important thing that you were highlighting in the blog post was the importance of trust in the system. That seems hard because, as we just said, it's going to fail sometimes, but then you're into this trust scenario. So talk about the balancing act there.
It's hard for different reasons. It's hard both because people will not trust it. And then some people will trust it too much. And those might be, just different people using the exact same product. And so you kind of have to design for differing levels of trust and comfort with the technology, differing levels of acceptance, all at the same time. And I feel like you don't really have that trust problem with like deterministic systems, right? You're designing the form field, like, yeah, people trust that like it's going to send my values in. So yeah, I outlined different ways to do that, but I think it kind of comes down to having a sense of knowing why, or understanding why some particular like output came about. And that might be just through repeated experience of like doing something many times and seeing that it, generally turns out well. That might be allowing folks to actually kind of see and check the outputs in real time, or looking back at historical data as well. So there's a lot of different opportunities to try to build that trust. But I think the key part is that you're going to have folks who just have vastly different levels of trust and acceptance of the system, all using it at the same time. And so you have to try to cover all of those spaces.
Mm. I know that for us, a big part of the work of getting Finn to behave the way we really wanted it to was to limit what it could do and put some degree of safeguards around what it can do. And that's obviously going to impact the trust as well. Yes, you have people who maybe naively don't even understand and shouldn't probably be expected to either understand what's going on behind the scenes here. Then you'll have other people who are going out of their way to try and get it to say something it shouldn't. And so there is a super broad spectrum there already. I think this will change over time as well. Or do you even see it changing? Like, have you seen, let's say, I'm not sure now, but we've had Finn in the market for more than half a year, I think, right? Have you seen the sentiment out there in the market, not among technology people, but among normies, users around AI systems? Or do you anticipate that the sentiment will change over time?
I'm definitely seeing more acceptance and excitement to use AI systems now than I saw, 5 years ago when I first kind of started working in this area. So
You've been in this for the long haul, Molly.
And the LLMs, like now that so many people have such a visible like method of using it and testing it out in their own personal lives, I think there's more trust, there's more excitement and willingness to try it out. There's still a lot of, one other thing I mentioned is like user expectations can often be like a big stumbling block in these projects. People sometimes just want everything to be exactly magical, and that can be very difficult to build. There's a lot of trade-offs. Like even with Finn, we put a lot of constraints to make sure that Finn was not behaving poorly. That has an impact on Finn's conversational abilities and things like that. So there's a trade-off to balance often with the trust issue and making sure that you are controlling the system as much as you need to, but not constraining it overly much.
Yeah, super interesting. At times it feels like you're more like a lion tamer than a designer now, right? Or you're both together. Molly, we'll wrap it up. You finished your post by talking about patience actually as being like an important trait to carry into designing with these systems. Why patience?
I think people are really excited like I said, people are really excited now to try out and like use AI, but there are still issues with data and trust, I guess. Often they might just you might not have the right data yet, right? So going back to the early example, like if your knowledge articles, your help articles aren't like good enough, you need to fix those up. And so there's an excitement and then the reality of actually implementing that. And that can take a long time. And so as the designer, you're seeing like, people are so excited. They really want this. They love it. Like the user testing was so great. The feedback. And then why aren't they having so many conversations live yet? Like what's the holdup? And there is kind of a reality that hits folks that like, it feels like this should be using LLMs should make it just like so easy and magical to launch. But there is still a lot of kind of work behind the scenes in the system to make sure that it's really usable and like good quality.
I share that sense of like the future is here, but it's not evenly distributed. And a lot of the distribution is actually old school deterministic product onboarding and product education and setup flows and things like that. So as you said at the start, this is a totally additive thing in addition to a lot of our, existing design skills and methodologies, which I think are still very relevant. And you make a great point. Let's not like lose sight of all of that foundational stuff that is still extremely important. This is like one more tool in the toolkit, but not a complete track change. It is an additive thing. Hey, thanks a lot, Molly. You, I gotta say, have been one of the people who's spent several years trying to tame the lion the hard way and learn these lessons. So I really appreciate you sharing it with our audience. Thank you.
Yeah, thank you, Emmet. Appreciate it.